important 1C is to make sure we can use the Pythagorean theorem to find sides of a triangle, all right? So if you look at this problem, the theorem states if A and B are the lengths of the legs. So notice here the legs make up that right angle, and that's a key thing, okay? Whatever two sides come together to make up that right angle, that's called the leg. And then the long diagonal is called the hypotenuse. So the two legs squared added together equals the hypotenuse squared, okay? So he was a Greek a long time ago. It's crazy to think, did he know when he found this theorem that it was going to last thousands of years? You know, it's kind of neat to think that way. So the key thing is, guys, to make sure you have the number in the right spot. Otherwise, it's not too hard to do it. So what we're going to do is we're going to say, what do we have? We have one leg, A and B. And it doesn't matter which one's which. We have the legs. Who don't we have? The hypotenuse, C. Okay? So we're just going to have A squared plus B squared equals C squared. So what we're going to do is we're going to fill in our legs. Does it matter where 8 or 6 goes? No, they're both legs. So the 8 can go first, the 6 can go first. It doesn't really matter. So this is 8 squared plus 6 squared. We don't know C, so he's going to stay that variable in our equation, C squared. And then if you know the squares perfect, if not, throw them in your calculator. 8 squared is 64. 6 squared is 36. C squared. What do? We add the two sides with 64 plus 36, 100. And is that our answer? No, right? Because 100 is C squared. We don't care about C squared. We care about C. So yesterday we learned about how square roots are the inverse of squaring, right? So if we want to get C by itself, we're going to take the square root so C pops out, right? We have a pair of C's that can pop out. But if we're going to take the square root on the right, we've got to just take the square root of the left. And so what's the square root of 100? 10. Key thing with these, a lot of them have either a word problem or even with the triangles, they're labeled. So the answer is actually 10 feet. Okay? So they're going to be looking, you remember how I have a love-hate relationship with my math lab? One of my hates is that a lot of times they fill in that unit for you. So they'll have square for you to fill in, and then feet behind it. But on worksheets and exams, I'm looking for those labels and those units, and it's hard because you don't get to practice with it a whole lot. So on your worksheets, I'll kind of give you a slap on the wrist. I won't take off on your worksheets, but I'll say units, you know. So hopefully by the time we get to the test, we don't forget about them. All right, here, this one's a little awkward because 1, it's turned on its side, and 2, we have a root in there. So I want to make sure we feel comfortable. Guys, since they are coming together to make that right angle, they are both our legs, okay? We still have A and B. So we're going to have A squared plus B squared equals C squared. I write that generically each time. Do you have to? No, okay? So we have 5 root 3 squared, all of it. So that's why I put it into parentheses, because if you don't put parentheses around it, you're just squaring the root part, okay? Plus 10 squared equals C squared. So this is what's interesting. If you remember to write it like that, you can actually put it in your calculator exactly like that, and it'll give you the correct answer, okay? So we'll type 5 square root of 3, and then we'll put parentheses around it. I forgot to put parentheses around it. Make sure you put parentheses around it. So we have parentheses 5 square root of 3 squared, and you should get 75. You're like, well, where did that come from? How did they get that? What you do, guys, is you actually square both parts. You square 5 to get 25, and you square the square root. They undo each other, so you just get 3, and 25 times 3 is 75. But when you want to put it in your calculator, make sure you have the parentheses around the entire thing so it knows to square both the 5 and the root 3, okay? So that part will be 75. This part's 100. So we get 175 equals C squared. And again, we know we don't care about C squared, so we're going to take the square root of both sides, guys. The square root of a square, he always pops out to be C. And then 175, I always throw him in my calculator first to see if he's a perfect square. And if he's not, I go back to the instructions to say, okay, did they want me to like reduce it in radical form, or can I just round? And if you go up here, it says round to 3 decimals. We don't have to do a whole lot of work. We'll just round to 3 decimals. Ooh, that's dark. 228 has a 7 behind it, so that will turn to 229. So C is 13.229. So that is going to be our answer with centimeters. Is that all right? If you guys are kind of like me, like I don't necessarily like my variable on the right side. Since it is an equation, you can flip-flop everything, okay? So you can have c squared equals a squared plus b squared if you want. So then you have that variable c on the left side the whole time you do it. It's up to you. On this one, the only difference is now notice that we are given a leg and a hypotenuse, so we don't know b or a. I don't care what you want to call it. It doesn't really matter, but we don't know one of the legs. So we have a squared plus b squared equals c squared, where technically I have a, so we have 3 squared. Do I know b? No, he's going to stay b squared. And then my hypotenuse is 7. Okay? This is very similar. There's just one little bit of information we have to do that's different than the other side. All right, square what you can. 3 squared is 9. We don't know b, so he stays b squared. And 7 squared is 49. Okay, so this is where technically in this class you might not know how to solve equations, but I think all of you have the math background to know what to do next. We want to eventually get b squared by itself, so what do we need to do next? Subtract the 9 over. We're going to actually talk about solving equations like in a couple sections, but whenever you need to get something isolated, you always do the opposite operations. Right now, 9 is added to this, so what's the opposite of adding 9? Subtracting 9. So what we're going to do is we're going to subtract 9 over. Why? What's 9 minus 9? Nothing, right? And we get b squared by itself. But what's 49 minus 9? 40. Okay? And you'll always do that. If you have the hypotenuse and you're missing one of the legs, you'll always have to subtract the number over before you take the square root. Okay? So we're going to take the square root of both sides. The square root of b squared pops out to be b. The square root of 40, it's still with the same instructions where we're going to round to 3 decimals, okay? So we're going to just pop that into our calculator to see what we get. 6.324, but what's behind our 4? A 5. So it'll be 6.325. And our unit is meters. Another thing to keep in mind with my math lab is even though we're calling it A, B, or C, a lot of times they don't want you to say B equals. They just want you to say 6.325. So kind of keep that in mind because you might type B equals and you get a red X. It's because they didn't know you called it B. You know, they didn't give it a name. So just pay attention to that. All right, so the next thing is kind of just a real life example where you might use the Pythagorean theorem. A lot of times I feel like you're using it to find this distance or this distance. This distance on the ground is usually easily measurable, but we'll go along with it. So it says the tallest structure in the United States is a TV tower in Blanchard, North Dakota. Its height is 2,063 feet. A 2,382-foot length of wire is used as a guide wire to hold the top of the tower straight. We are supposed to approximate to the nearest foot how far from the base of this tower should that guide wire be, okay? So we don't know A or B, it doesn't matter. It doesn't matter what you call it, okay? So notice we do have the hypotenuse, so we are eventually going to subtract over. So we have A squared plus B squared equals 2,063 squared. So we'll get some big numbers. That typically happens, guys, in real life, though. Like, these perfect little algebra problems that they can give you always look nicely and aren't as scary. Real life stuff looks kind of scary. So, oops, I wanted c squared there, sorry. I wanted to keep it generic, my fault. C squared, okay. Now I'm gonna fill in my A's and my B's. So I have 2063 squared plus B squared equals 2382 squared. So not only did I put a number up there, but I put them in the wrong spot. I'm sorry about that. I wasn't paying attention to what I was doing, okay? So, does it matter where the 2063 goes? No, as long as it's one of these, that's all that matters. So throw that in your calculator, 2063 squared, it's big. Okay, what do we get? 4,255,969 plus b squared equals, this will be even bigger, 2382 squared. Make sure if you worked ahead that you're getting the same things I am, because I could be messing up even. Does that look right so far? Yeah. Isn't that crazy big numbers, okay? So it usually works out, though, that by the time we subtract and take the square root, that whatever answer we get will be relatively close to the other two. So I'm going to subtract this guy over. I'm not going to actually write him. He's going to cancel. And so I'm going to type in my calculator that 5 million minus the 4 million. and I get, what is that, 1,417,955. Okay? And so at that point, I'm like, well, I don't care about b squared, I care about b. So what I'll do is take the square root of that. Something that to kind of keep in mind when you're working with your calculator, that's not the hugest number, but you can take advantage of our keys on a calculator. If you hit second square root, and instead of typing that entire number, notice down here above the negative sign it says answer. If you hit second answer, it'll take your previous answer and just shove it in there, so you don't have to type it again. So I want to take the square root of that number, so I'm going to hit second answer, and it finds the square root for me without me having to type. Not the biggest deal in the world, but little shortcuts like that might help you out. So I got b, when I took the square root of both sides, 1190.779, but what did it said round to the nearest foot. That means the nearest whole number, right? So what's behind that 0? Technically a 7. So we're going to round to 1,191 feet. But do you see how that number's relatively kind of close to the other two numbers? So if you do this and you get like 2, you know you've done something wrong. If you do it and you get like 5 million, you know you've done something wrong. So these sides are always going to be kind of similar in size.